our next session of Devtoberfest. This is Thursday, therefore this is data and AI track. We've had quite a few sessions already today. If you didn't manage to join them live, then please watch recording. And my name is Vitaly Rudnitsky. I am one of SAP developer advocates who brings you this event. And it is my pleasure to introduce our next speaker, who will talk about Retrieval-Augmented Generation, or sorry, there are so many TLAs or three-letter acronyms that I've heard today that I needed to think for a minute for what this next acronym will be. Jaylin, stage is yours.
Thank you so much, Vitaly. Hello, everybody. Let me just quickly go into my presenter mode. Alrighty, thank you so much for the introduction. I'm a senior software developer at the SAP Enterprise AI Search team, and I'm really excited to be talking to you guys about data optimization today. And as you can see, my topic is pretty self-explanatory. Want better RAG results? Optimize your data. Let's dive right in. So what should you expect from this session? We've got a few refreshers that I want to go through with you. Then I'll cover a bit of background, then the main idea of this talk. Then I'll show you a quick demo and some key takeaways. So let's get right into it. Starting with some quick refreshers. And I know many of you are probably familiar with these, but I think it's always nice to have them. So I want to start with the origins of generative AI. And you might be very familiar with this gentleman on the screen. His name is Geoffrey Hinton. He's also known as the godfather of AI because of his contributions to artificial neural networks. He thought, how can we make a machine learn similar to humans do? And thought of modeling this concept using how different neurons in our brains get fired. He was co-authoring a paper published all the way in 1986 that popularized the backpropagation algorithm for training multi-layer neural networks, just like in our brain. And as you probably know, that backpropagation is the foundation of machine learning. And now to put this into a bit of perspective, ChatGPT was released publicly in November 2022. So this first paper was published 36 years prior to that. And it's really where all the core machine learning work started. And now,
Sorry, Jaylin.
Yeah.
Just, I don't see your slides.
Oh. Oh no. Were you seeing them halfway through?
They're coming now, and I can see them now. Sorry, I thought that you were still on like general introduction.
I'm so sorry. I thought I was going through the whole thing. So did you see the agenda and the refreshers and everything? Nothing?
No.
Whoopsie, my bad. Okay. Let's see.
Okay.
Can you see them now?
All good.
Okay, great. I mean, agenda, straightforward. I think you guys are probably with me, quick refreshers. And yeah, this part I thought was kind of interesting, but let me quickly go through it. I was talking about Geoffrey Hinton, who is known as the godfather of AI. And yeah, he basically co-authored this paper called Learning Representations by Backpropagation Errors, published like 36 years ago. And ChatGPT was published 2022. And now the next gentleman, his name is Ilya Sutskever. And he used to be the lead research scientist at OpenAI and contributed hugely to the development of ChatGPT. So actually a fun fact, he was also a student of Geoffrey Hinton when he was still a computer science professor at the University of Toronto back in 2012. And Ilya published a paper just over 10 years ago that changed literally everything. And more on that in just a little bit. You can still see my slides, right? Yes. Okay, great.
Yes.
Oh, great. Thank you for confirming. Now I want to cover Retrieval-Augmented Generation workflow for documents. And many of you are probably familiar, so it'll be just a quick refresher. So we've got our input data, and we want to basically process each document. We want to split each document into smaller subsections called chunks, and this is the process called chunking. Next, what we need to do is send these chunks into an embedding model. And this is basically a way for machines to interpret regular natural language. For example, dogs are awesome is a string, like a sentence, and this will be converted through the embedding model into a vector format where it's called an embedding, and this is going to be, and machines are able to interpret this. Next thing that happens is for every single chunk that gets embedded, that gets stored into a vector database. And now we've got our user who has a question for the LLM. And let's say the user asks, how can I reset my password as the question? Now the LLM needs two things to process this. It needs a question embedding, and it also needs document embeddings. So the question, the natural language question, goes into the exact same embedding model as we used to embed our documents, and we get a vector representation of our question. And this vector representation, or this embedding, then gets compared to all the vectors in our vector database, and we get the top K vectors for our document embeddings. So these are then fed back into the LLM, and we get an answer, and our user is happy. All right, now that we covered some refreshers, we're getting more into the background of this talk. So where did this idea for the talk come from? There were actually two key components to it. The first one was me attending the NeurIPS conference at the end of 2024. And the inspiration came from a single talk, actually, which was about making better use of our already existing data. And we have a lot of data in search. We index many different sources, such as some gated content like knowledge-based articles and SAP notes, and also some public content like SAP Community, which you're probably very familiar with, and also SAP Help documents. And this all made me think, how can we at SAP can extract the most out of our already indexed data? And quickly wanted to cover also what NeurIPS conference is. So it's NeurIPS, or Neural Information Processing Systems, is one of the largest and most prestigious AI and machine learning conferences in the world. And it's a very technical and hands-on conference. It brings together the data scientists, researchers, and machine learning engineers from all around the world for exchanging of methods and results with the latest machine learning trends. So it's really to bring people together who are like really experts in their fields to push us forward and further towards new innovations. And it's also where some of the most influential machine learning advancements have born, and more on that in a little bit later. So as you can see from this graph, the conference attendees have been growing exponentially since it was founded. And last year, the number of total attendees was almost 20,000, which is probably the most number of people I've seen in one place since COVID. And since it's a traveling conference, last year it was being held in my hometown, Vancouver, Canada, which was also an amazing occasion for me to bring out my Canadian pride. And there's a vast number of research topics that were covered here. So all of these dots were papers and presentations that were presented at this conference. Remind you that it was like a week-long conference. And there's things all the way from like LLMs to reinforcement learning to multimodal LLMs, causal models, AI ethics, benchmarking, and many, many more.
Jaylin, sorry, can you check sharing this slides
Oh my gosh,
again?
It got lost again?
Just
I'm
a couple of seconds ago.
I'm sorry. Thanks for letting me know. I'm not sure why this is happening. Can you see them again?
Yes.
And,
So we were on this
here,
slide.
Right?
Yeah.
Okay, perfect. Great. And hopefully it doesn't happen again, but please let me know if it does. Yeah, so this was all the different research topics, and all the dots were represented were just like papers and topics that were presented. And you can even like check it out at the link here as well. All right, but what really stood out for me was the Test of Time Awards, which are given to papers presented at this conference 10 years ago that had the most influence in the machine learning field today. And one of those awards was presented to a paper I mentioned before called Sequence-to-Sequence Learning with Neural Nets by Ilya. And this paper was very bold for its ambition and scalability. It showed the end-to-end sequence architecture that enabled the most impressive language model of its time. And before this paper was published, we were using methods like bag of words or TF-IDF to really convert regular text and natural language into machine-readable format, which was, and it was really almost impossible to retain the semantic meaning of everything. But this paper proved that you can encode an entire sentence in an embedding. And it really paved the way to our modern day foundational models. So what was really cool then was Ilya came on stage and gave a quite inspiring talk. And the most concerning point for me was that the biggest limitation of Gen AI is the finite amount of human generated data that we have. So the compute power is growing, yes, and very fast too, with better hardware, algorithms, and larger clusters by day, but the good quality human-generated data isn't. And Ilya even joked and said, data will actually become the fossil fuel of AI. So what comes next? Yes, we can start generating synthetic data to mimic human-generated data, but and I think some people are already doing this, but it's costly and it's really not the same as having access to good quality human-generated data. All right, now we're down to the main idea of the talk. Ilya's words on the fact that data is not growing and will become the new fossil fuel of AI really stuck with me, actually. And it got me thinking, even with human-generated data, our retrieval-augmented generation workflow results may not be optimal, because we know that having poor quality data, potentially coming from poor extraction from documents, leads to suboptimal chunking, which leads to loss of important context and ends up yielding lower retrieval precision. So what can we do about it? Could we not obtain better results from our RAG pipelines by simply optimizing our input data and get the best out of what we already have? The answer is, of course, yes. Please don't read the slide. I know there's a lot going on here. I just wanted to show you the paper that I got the inspiration from. And this paper is called Not All Tokens Are What You Need for Pre-Training. And it was presented by Microsoft at the NeurIPS conference. And it also got the Best Paper Award for that year. And it talks all about scoring pre-training tokens using a reference model, then training the language model with focus tokens with higher excess loss. So we can improve the quality of our RAG models by only training on the important and relevant information. Essentially, spending longer on the pre-training phase can really improve our end results overall. And having lots of data in the search team, like I mentioned, there's a lot of potential here for us. All right, so what did the paper mean by not all tokens are what you need for pre-training? Let's go step by step and start by understanding what selective language modeling, or SLM, is. So normally, sorry, just to check, you can still see my screen, right? Okay, so I can continue. Normally, causal language models like GPT train on every token in a sentence. And you can see that on the left side of this figure here, where each word from the sentence got included in the tokenization. But SLM does something different. It looks at each token and asks, is this token really important for what I care about? And it ignores tokens that do not add real meaning. For example, some random dates or some noise. And these are shown.
Sorry, the moment I confirmed I see your slide, it disappeared.
It disappeared.
3 seconds. 3 seconds after that.
Oh my goodness.
So demagogues are not on our side, but we are doing all right.
Oh my gosh. It's good.
Just give it a second.
All right. Let's see again. Maybe.
It's coming now. Yes, we are on the same slide.
Yes. Okay. All right. It's going to be like a bumpy one, but that's okay, as long as you can see them. Okay, maybe I start this one. over. So basically, I wanted to explain the difference of selective language modeling. And normally the causal language models like GPT train on every single token in a sentence. So you can see on the left side of this figure where each word from the sentence gets included in the tokenization. But SLM does something a little different, like I mentioned, where it looks at each token and asks, is this token really important for what I care about? And it ignores tokens that don't add real meaning, such as like this random dates or some noise like this. So in the right side, you can see that the red tokens are dropped and not kept, because SLM only focuses on important high loss tokens. For example, words that carry meaning, rare words, domain-specific words, and ignores all the noise. Now, let's consider our usual RAG workflow. We have the input data, which is denoted as the original corpus here. And this is passed into the LLM for inference. And we expect to get our standard question answering results. And now let's take a look at the proposed workflow from the paper. The paper suggests that we should create a pre-training corpus, which is just a fancier way of saying we should pre-process our input data before using a reference model to get the best out of it before feeding it to the LLM. And here on the left, we see the first step is to feed our original input data into a reference model, which trains on our high quality text and calculates the perplexity of each token in the pre-training corpus. And perplexity, or a loss score, is basically a measure to see how well a language model predicts a sample of text. For example, it's a way of saying, how surprised is the model by the next token? So a low perplexity means that the model can predict the tokens well, and it wasn't surprised. And a high perplexity means that the model encountered a word that carries meaning because it's not very common. For example, these could be rare words and more domain-specific words. And next, we use this pre-training corpus of good quality tokens to determine how to pre-train our LLM and that is ready to be used for inference. And since we already feed the LLM with fewer tokens of highest quality, it already has a faster compute time and saves on costs. And this is because we're only processing a handful of tokens instead of the whole entire noisy input data. Remember, not all tokens matter for pre-training. The paper used the row1 model for their reference model, and this is actually shared on GitHub and is publicly available on Hugging Face as well. So here I want to share some results with you. We've got two graphs showing the average few shot accuracy of two models. In red, we see the row1 model, and that's trained with the proposed selective language modeling. And in blue, we see the baseline model trained using a causal language model like GPT. And SLM improves the average few shot accuracy of a math data sets by over 16%, achieving baseline performance of 5 to 10 times faster. And it's really important to point out here that this performance improvement of almost 10 times is the result of manipulating the input data only. We have not even touched the LLM fine-tuning step. So this is all coming from, if you remember the slide from previously, this is all coming from before the inference phase, which I think is very powerful. So focusing only on the pre-training and pre-processing the data. Cool, now let's talk about the demo. So in my case, I took a bit more of a simplified approach to SLM, as this is already a pretty time-consuming task. And yeah, so basically what I did is I used this pre-training corpus as the input to our original LLM, where only the tokens with higher loss score are kept and remove the ones with lower loss score. And in this demo, I use the externally available SAP Help documents and also use the SAP GenAI Hub AI Core LLM endpoints as well. What I did was I loaded a reference model, then I defined a function to compute the token level losses or perplexity for a given chunk. then using the token losses to select the high loss tokens and filtering chunks on these high loss tokens. So only keeping the tokens in a given chunk that are important while keeping the semantic meaning, then create a pre-processed data set containing only these filtered chunks and embed the filtered or good quality chunks before sending them to the LLM. Let me now show you the results. So at this point, let's see, can you still see my screen? Okay, so at this point, we've got our chunks that are that have SLM applied. Yeah.
So actually, I was waving that the moment you switched, it disappeared.
It disappeared again. All right.
But that's
I don't
okay.
know why. All good. Keeping the energy high. How is it now?
Yes.
Good. Good. All right.
We're
So we're good. Awesome. All right. So yeah, I wanted to show you guys kind of the results of the fit the time. How are we getting time? Yeah, for the sake of time. So this is making an LLM request after we've got our SLM applied chunks. So we want to first embed the user query. Then the step 2 would be to compute similarity between the query and the documents, regular RAG workflow, and we load the config of the different the GenAI Hub endpoints, the API key model, and the URL. And here, sending it the retrieved chunks to the LLM for answering. And here is, sending everything to the LLM with the query. So important part I wanted to show is the results. So when the SLM was applied to our input data, for example, when the user query is explain the different SAP Signavio process inside supply chain API endpoints and how to use them, we get the these top retrieved chunks and the answer below. So you can see that chunk 1, the confidence score we got was 0.62, and for the second one is 0.62, and the third one would be 0.43, and we get a nice answer from the LLM as well. But if we compare this to the LLM results with the original input data, where we did not do any pre-processing at all with the exact same question, you can see that the retrieved chunks are a bit different, and also they're yielding a lower confidence score as well. So what that means is that even though we sent a less number of tokens and a smaller subset of input data, we still got a better response from the LLM. All right, now going back. Can you still see my slides?
Yes.
Great. So this was my kind of simplified approach to SLM. As I told you that I use like a function to determine the high loss tokens and compare computing the token level losses. Whereas in the actual paper, they use a reference model that was pre-trained. So that's why I wanted to quickly go through the too long do not read version of SLM from the paper. And in essence, what it does is it uses this row 1 model, which is a small, high quality pre-trained language model. And this is used to score each token by its log probability or perplexity. So the tokens with higher excess loss or higher perplexity under the reference model are then selected for focused training of the main model. And replicating this, of course, requires collecting and curating token corpus and initializing and training reference LM language model with specified hyperparameters and integrating it into a token selection pipeline. And there is different steps to go through, the why we're using a reference model and how to train our reference model setup. But I think these are a bit too low level, and maybe we can kind of skip to token scoring and selection. So how this is done is it goes through a forward pass. So basically running the reference model on the entire unlabeled pre-training corpus to compute per token loss first. Then the computing excess loss happens. So then we do ranking of tokens. So basically sorting them by descending reference model loss. And lastly, selecting the top fraction of them. And lastly, we basically integrate all of this into the main pre-training. So we start with initialization, then we have a pre-training loop, and optionally we can also do checkpointing to update selection at the different billion tokens to evolve to adapt to the main LLM's evolving distribution. So that might have been a bit much technical details, but I think we're down to the main idea of the talk. Basically, I know I gave a lot of information to you in a very short time, but I really promise that this is my last slide. And so after that, we'll give you a bit of a break. So you might still be wondering, why are we using SLMs? Is pre-processing the input data a waste of time, effort, and energy? Actually, I would say it's quite the opposite, because as I mentioned earlier, we're slowly running out of the good quality human-generated data. As you know, when you ask a short question to at any LLM, you get like a huge paragraphs, and it's very verbose. So good quality human-generated data is really dwindling, and we should really try to use the data that we already have more efficiently, and we can make a huge difference in our RAG results before the inference phase if this is done properly. So some of the benefits of SLM include that it doesn't waste capacity learning useless words. It gets smarter at rare, important, and useful knowledge. It becomes more efficient for knowledge tasks such as RAG, and it reduces resource usage when used prior to the inference step in a RAG workflow. By extracting the most relevant tokens from the input data, passing these more specialized and reduced number of tokens to the LLM, getting relevant and good quality results, and while also saving on costs and being more sustainable for the environment. And with that, that's all for me. Thank you so much for listening.
Thank you, Jaylin. There are no questions in the chat, but let me ask to understand this. What you presented, is it a research or is it a part of some SAP solution already, or what are the plans? What do you plan to do with this?
Yeah, so this is part of the research work stream as well, our incubation work stream. So what we're planning to do with this is integrate it into our document grounding system, because what we're doing right now with the search team is we provide document grounding with the indices. So we provide that with the knowledge base articles, SAP notes, and all of the resources. And some of them, as maybe some of you might know, the SAP Help documents and SAP Community could be quite noisy because there's a lot of text that's generated there. So this is to kind of denoise it and basically give document grounding team a better quality data set, which then will improve results for Joule and every other Copilot that we have.
So have you done any preliminary research? What is the percentage of this noisy data in the sources of documents that we are using right now?
Yeah, unfortunately, I don't have the exact numbers, but depending, for example, SAP notes and knowledge-based articles are fairly good quality, whereas especially our public ones like SAP Help documents and SAP Community has quite a bit of noise. And this is why, and they're really long documents. So that's why reducing the number of tokens we send to LLM would also help with costs for the environment as well as SAP.
Thank you for answering that. And I believe the last question from my side, because people hear as well a lot that we are mentioning that SAP had this strategic partnership with the company Perplexity, just to make sure these are just two same names, but this is not that you are using anything from Perplexity, the company or the product.
No, not at all. Yeah. Perplexity is completely, and in my case, or how I use it is completely in machine learning terms, where it's like the token loss score. Yeah.
Okay. But I believe it was important to clarify because, as I mentioned, we hear a lot from our executives about this strategic partnership.
Totally,
as well.
yeah. And I think it's really cool that SAP is partnering with Perplexity. I think that's amazing.
Okay. I believe that's all from my side. for the moment, there are no other questions in the chat, but let me remind everyone who is listening this live or watching the recording that there is a question from Jaylin that you should answer if you want to get points in our Devtoberfest contest. So this question has been published in the live chat. If you want to answer it now, or if you're watching the recording, then please look into the description of this session and you should find it there. With that, that's all from my side. Jaylin, anything else from your side?
No, I think I just want to say that thank you so much, everyone, for tuning in or watching this recording a lot later on. And it has been my pleasure being part of this Devtoberfest.
It was our pleasure to have you as a speaker as well. With that, have a good rest of your day. And for everyone watching, thank you for joining. And we hope that you enjoyed this Devtoberfest sessions today. Take care. Bye.
Thank you.
Okay, I stopped streaming.